So in today's video, we're going to discuss chapters 4.5 and 4.6. Part of 4.5 I put in yesterday's video. I started talking about it, but we're going to carry on that conversation. And then 4.6 is super short, and the homework for that is super short as well. So first of all, let's look at 4.5, which is analysing group data. We already looked at whether you've got a population or a sample. We looked at the mean of grouped data. So group data is just where we are given a frequency distribution. So we have our classes and the frequency of each of the classes, how many things fell into each of those classes. But we don't have the distinct data points. So we don't know what the exact data points were for each one of our population or our sample points, but we know how many data points fell within a certain range. And we know that for each one of our classes. So we already discussed this, but if we've got the population mean of grouped data, we said that it was the sum of each of the frequencies of the classes times the midpoint of that associated class, and you're going to do that for every single one of our classes. You're going to sum all of those up, so you're going to add them together and then divide by the number of data points that there were. So you're going to divide by the number of data points in your population. This n, the number of data points, can be figured out by just adding up all of the frequencies of the classes. In the exact same way, if we wanted the sample mean of grouped data, okay, it's the exact same calculation, it's just that you are treating this as a sample, so the notation is very slightly different, but the actual calculation is the same, it's just the notation is different. So it's the frequency of each class times the midpoint of that class. Do that for every single class, add those results together, and then divide by the number of things in your sample, the number of data points in the sample, which again is just the sum of the frequencies of the classes. This can actually be done on a calculator. Please do not do this by hand if you don't have to, okay? The calculator can do this for you. Once you've got the midpoints of each of the classes, you've already got the frequency of each of the classes, we can actually do this on a calculator, which I'll show you in a second. I just want to talk about the variance and the standard deviation first. So let's say that, again, we're looking at data which represents a population. So we've got a whole population of things here. And we want the population variance for this group data. So again, our data is grouped into classes, and we want to know what the variance would be for this grouped data. This is not a very nice formula, so please, please, please do not do this by hand, okay? I'm going to talk about how it's calculated, but you're never actually going to have to do this by hand. The calculator will do this for you. So you'll see here, it looks kind of like a normal population variance, okay? Where we've looked at the difference between a data point and the mean. Then we square that difference. Then what we did before was we just added together the squares of the differences and divided by the number of things in the population. Here it's almost like a weighted variance. You are weighting it by the frequency of each of the classes. So I'm going to take each of my classes and again find the midpoint of each of the classes. Then for each class I'm going to do the midpoint minus the mean, okay? Then do that for every single one of the classes, midpoint minus the mean. I'm going to square each of those differences. Then once I've squared the differences, I'm going to multiply it for the frequency of that class. So I'm going to do midpoint minus the mean, square it, multiply it by the frequency. And I'm going to do that for every single one of my classes and then add together the results, okay? I'm going to sum together each one of the midpoint minus the mean squared times the frequency. Then I divide by the number of things that I have in my population. The sample variance is very similar, but if you remember when we looked at variances before and we looked at standard deviations, we actually divided by something that is slightly different. So we didn't divide by the number of things, in this case it was a population, but we didn't divide by the number of things in the sample. What we actually do, so S squared denotes a sample variance, sorry. So S squared is a sample variance, and we're going to sum together each of the midpoints of the classes minus the mean of that group data. Now remember, we've already got the means of each of our group data, okay? So we already know what X bar is if we're looking at a sample, and we know what mu is if we look at a population, because we can calculate this as we did on the previous page, okay? So I'm looking at the difference between each of the midpoints and the sample mean for this group data. I square those differences and again multiply it by the frequency of that class. I'm going to do that for every single one of my classes and add them together, add together those results. But now I'm going to divide by the number of things in my sample minus 1. Okay. Again, these are horrible formulas. I do not expect you to do this by hand. I do not expect you to remember these, but I just want you to kind of see where this is coming from. They look very similar to our original variance formulas, but now it's like you're weighting each one of your terms by the frequency of that particular class for which you're using the midpoint, okay? So you're weighting each one of these terms. So that's the only difference. We have an example here, and I'm going to show you how to do this on a calculator. I've already gone through this, but we're going to talk about it and we're going to go through this on a calculator. So you'll see here, it's looking at the shelf life of roses, okay? So it's got the days of shelf life, and we've got each of these in classes. So if a rose lasts between 1 and 6 days, we see that there's actually 2 roses that did that. And roses that lasted between 7 and 12 days, there were 3 roses that did that, okay? So we don't know exactly how many days each rose lasted, but we do know how many fell within a certain period of time, okay? So what I'm going to do is I found, whenever you get one of these frequency distributions and they ask you for the mean of the group data, or they ask you for the variance of the group data, or they ask you for the standard deviation of the group data, the first thing you are going to do is to find the midpoints of each of the classes. Always make that your first priority whenever you see mean, variance, or standard deviation of group data, okay? So I've gone ahead and found the midpoint of each of these classes. Again, all you do, let's say we're looking at the first class, I'm going to take each of the endpoints of the class, add them together, and divide by 2, which would be 7 over 2, which is 3.5. And do that for each of your classes. So I've got my list of midpoints. You can put them as like an extra column if you're like taking some notes when you're taking a test or your homework. Just make an extra column in your frequency distribution table and you can write down the midpoints. Now what you're going to do is use your calculator, okay? I do not expect you to do this by hand. So we're going to go ahead and use our calculator, and we're going to use one variable stats on a couple of lists, and I'll show you how to do that. And then our calculator is going to give us back the mean and the standard deviation, and from that we can always find the variance of this group data. So let's go ahead and do that on a calculator. Okay, so what I have gone ahead and done is under my list, so if I go to stat and edit, you'll see in my lists, I've made list 1 as the list of my midpoints and list 2 is the list of my frequencies, okay? So you put each one of your midpoints in a list and each one of the frequencies in a list. Make sure that for each row that a midpoint is in, the corresponding frequency of that class is in that same row. So don't mix them up. So I've got my list of midpoints and my list of frequencies. Now I'm going to go ahead and calculate this using one variable stats, but you're going to treat this in exactly the same way that you treated the weighted mean. Okay, as I said, when we looked at our formula for our variance for the group data, you noticed that it looked very much like the original variance that we were looking at for individual data points, but it looked like it was weighted by that frequency. So what you're going to do is you're going to put your list of midpoints as your data list and the frequency list as your list of weights. So let's go back to stat, calc, one variable stats, okay? So list one is my list of midpoints. The frequency list, my list of frequencies, they act like my weights, okay? So make sure that you've got the other list in there and then go ahead and calculate, okay? This top value, okay, whether you're looking at a population or a sample, that is the mean of your grouped data, okay? So you do not have to work that out by hand by doing the frequency times the midpoint for each class, adding them together and dividing by the number of things that there are, okay? You don't need to do that. This does it all for you. That is the mean, okay? You just have to determine whether it's a population or a sample if needed. Then, if you need your standard deviation, okay, again, determine if it's a sample or if it's a population. This SX value is your sample standard deviation for the grouped data, okay? The sigma X is the population standard deviation of the group data. So you have to determine from the problem, are we looking at a sample or are we looking at a population? Then you can pick off the standard deviation that is appropriate, okay? If it asks you for the variance of the group data, which had that horrible formula that we were looking at, remember that the variance square rooted is the standard deviation. So if I square the standard deviation, I'll get the variance. So that's exactly what you're going to do here. Instead of using that awful formula, you can just type these into the lists. Then you're going to go ahead and run one variable stats with your list of midpoints and your list of frequencies. Go ahead and calculate, then just find what your standard deviations are, whether it be a sample or a population. And then if I need my sample variance, I'm going to square this value here, so it'll give you roughly 64. Or if I'm looking at a population instead, this is my population standard deviation. So to get the population variance of the group data, I just go ahead and square this value. So that's all you need to do on a calculator. It is super simple and much easier than using those formulas. So please go ahead and do it this way if you need the mean, the standard deviation, or the variance, whether you're looking at a population or a sample. So exactly as we saw on our calculator, we had a mean of 18.73. Then our population standard deviation, I've kept everything to a population here, okay? I'm not treating these roses as a sample, I'm treating them as a population. So my population standard deviation was 7.85, okay? So the standard deviation is what comes up on a calculator. It does not give you the variance automatically. So what you need to go ahead and do is square that value and get your variance, okay? So whenever it says to you on a homework, okay, it may ask you for the population or sample mean, okay, we know where to find that. Then it will give you either the population and the sample standard deviation. So you need to know from the problem which one of those to pick. In this case, in this particular problem, it actually asks for the population standard deviation. So I'm looking at that value on the calculator that says sigma X. If it asks you for the population variance, I'm just going to square my population standard deviation. If it asks you for the sample variance, so I'm treating my data as a sample, then I would go ahead and find my sample standard deviation and square that number to find my sample variance. Okay, so just be aware you may have to do some more calculation in order to get that variance value. The only other thing to remember here, and I did mention this at the start of the 4.4 video, when you're calculating the mean and the standard deviation in the case of grouped data, where you don't have each specific data point, you just have the classes and how many fell into that class, but you don't have the specific data points. Just be aware that if we then went ahead and found the mean or the standard deviation for those specific data points, it would differ slightly than the mean and the standard deviation that I get for my grouped data, because I'm basically averaging out each of my data points in a particular class and saying I'm going to average it to the midpoint, and I'm going to treat my midpoint as though it occurs X amount of times in the frequency, okay, whatever that frequency is. So I'm basically assuming that all of my data points in a particular class average out to my midpoint, and saying that that midpoint occurs however many times the frequency of that class is, okay? So you may see a slight deviation in the mean if you had like the exact data list. There would be a difference in the mean for the exact data points and the mean for the grouped data for that same set of data, okay? So the mean for the grouped data and the mean for the exact data points may differ slightly, and the same with the standard deviation. But it's a good approximation if a frequency distribution is all you have and you do not have your exact data. It is a great approximation to see what your mean and standard deviation would be. Okay, and to round out chapter 4, we're going to look at proportions and percentages. Now, you guys have done this a million times before in math, so I'm going to make this super fast, okay? You've seen this in other math classes, and it is very simple and can be done on a calculator. So this shouldn't take too long, and the homework is pretty quick. So, what is a proportion? A proportion measures the fraction of a group that possesses a certain characteristic. Okay, so all a proportion is it gives you some kind of fraction normally, or it can be written as a percentage. It gives you how many people out of a total have a certain characteristic. So for example, let's say I've got a class of 30 students and I see that 6 people in that class are left-handed, okay? So if I have 6 left-handed students out of a class of 30, okay, then that tells me that 6 out of 30 are left-handed. Okay, you write it as a fraction normally. You can simplify it if you're comfortable simplifying fractions. Hawkes actually prefers it. So if you wanted to simplify this, 6 out of 30 is the same thing as 1 over 5. Then you can also write this as a percentage. So just as a quick recap, if it asks you for a percentage instead of a fraction, all you have to do is to get this fraction as a decimal. So divide numerator by the denominator and then multiply by 100. So all I would type into my calculator to get 1 over 5 as a percentage, I would just do 1 divided by 5 in my calculator, which comes out to 0.2, which is the same thing as 20%. If I multiply that by 100, I get the percentage, okay? So whenever you get one of these problems, a proportion just tells you how many people out of a total have a certain characteristic, okay? So the way that they talk about sample proportions and population proportions, okay? Again, it's the exact same calculation, it's just that the notation for this is slightly different. So let's say I'm looking at a population proportion. Okay, a population proportion is denoted by P, and it is calculated as X over N. X is the number of people with a certain characteristic. So in the case before, it would be the number of people that were left-handed. And N is the total number in the population. So in our case, we had 30 people in the classroom. That was the size of our population. Okay, to give us 6 out of 30 as we had before. Same kind of deal with the sample proportion. It just has a slightly different notation, just in case you ever see this and you need to know whether you're looking at a sample or a population. A sample proportion is actually denoted like this. We actually call it P hat, okay? It's like an upside down V that is on top of the P. That denotes a sample proportion. And again, it's the number of people in your sample that have a certain characteristic divided by the number of people in your sample. Okay, so as I said, it's pretty simple. I just want you to see the notation in case it does come up in a textbook or your homework, okay? But just remember, all you need to do is you see that there are X out of your sample or population that have this certain characteristic. So in this case, 6 out of 30 had this characteristic. You write that as a fraction as 6 over 30. So 6 out of 30 had this characteristic. If you want to, you can simplify that fraction. It is actually preferred if you can. So that comes down to 1 over 5. Then if it ever asks you for a decimal proportion or a percentage, to get the decimal, you just do numerator divided by denominator on your calculator. So in this case, either 6 divided by 30 or 1 divided by 5. That gives you 0.2. If you want a percentage, just multiply that number by 100 to get the 20% that I have here.